The IBM Asset Analytics for Rotational Equipment and Oil and Gas solution helps customers maintain control over their operations by providing the necessary situational awareness and decision support to stay on top of operations that span a large number of wells. In particular, it provides advanced warning of electric submersible pumps, or ESPs, that are most likely to fail, impacting production performance. The likelihood of failure and recommended action for each ESP at risk is presented so that an oil production executive or analyst can make informed decisions. This demonstration presents the experiences of two oil and gas operations role players for whom the solution is designed, namely an operations executive and an operations analyst. We open with the operations executive role. The executive dashboard that is displayed offers a snapshot of ESP performance across all ESPs residing in a location or site. On the top left of the dashboard, a map represents every ESP with its location and is color-coded to identify the current level of risk it carries. The color coding of red, yellow, and green identify high, medium, and low risk, respectively. On the top right of the dashboard is a tally of all ESPs that are represented categorized by failure probability criteria. The numbers within the red circle represent the total count of high-risk ESPs, within the yellow circle is medium-risk ESPs, and the green circle represents ESPs with low risk. On the bottom left of the dashboard are the key details or summary view of the worst performing ESP, which is displayed by default. The details include ESP name, location, appropriate vendor information, installation date, and current mode of operation. To the right are the details of why the pump is classified as high risk, represented as a horizontal bar. It also carries a numeric percentage value to the right of the bar. In this case, we can see that ESP 701 has a probability of failure of 85%. In the middle of the dashboard is a tabular display of information for all ESPs in the solution. The table represents the mode, probability of fault or outage, and any recommendations for each ESP. If I select a row or an ESP on this table, it will both highlight that as well as change the contents of the pump summary in the failure severity indicator. This enables executives to perform a broader investigation to compare underperforming ESPs against each other and also to understand patterns and impacts. On the bottom right of the dashboard is the oil production performance across all regions of the solution over a historical time frame. Each region is presented by a color-coded histogram, and by default, the historical time frame is the past few years. We can use these radio buttons here to select between a yearly and a monthly and a quarterly view. So let me select monthly view, and you can see how the chart changes. If I go up above, we can scroll and see all of the ESPs that are included in the within the solution. And if I select one of these ESPs, you'll see that the pump summary information will change. So let's select ESP 102, and we'll try to get a better understanding on what's going on and what information is behind that pump. So you can see when we selected ESP 102, the pump summary information changed, and it updated the likelihood of failure for that particular pump. Using this dashboard and the information displayed here, the executive now has enough information to recognize the severity of the impact of the worst performing pumps. And at this point, she decides to contact the operations analyst to request further investigation to understand the imminent production impact. What we'll do at this point is we'll go ahead and switch over to the analyst dashboard, which is laid out in a very similar type of information, only a little more detailed. So now when the analyst hears from the executive, he logs into his dashboard, and by default, it focuses on the ESP with the highest at risk, which again you can see is ESP 701. In the top center of the dashboard located here are the key details or a summary view of the worst performing ESP, which is displayed by default. This widget is the same as the pump summary view in the executive dashboard. And again, you can see it has name, location, vendor information, install date, and current mode of operations. And then on the top right, we also have a tally of all ESPs within the solution. And here you can see we have two high risk ESPs, 0 medium risk, and 6 low risk. And then below that is the well test data for the particular ESP that we're looking at. So this is for ESP 701. And again, you can see the water cut percentage, the gas oil ratio, and the oil rate. And the gauges show the current operations, and you can see when it gets into negative territory, it goes from green to yellow to red. In the center of the dashboard, and spanning the width of the screen, is the change point analysis widget that displays graphs of historical performance information for the ESPs under investigation. And here you can see we have graphs for pump pressure, amperage, and temperature, as well as mode change point indicators represented by vertical orange and red lines. And then in the bottom most of the dashboard is the maintenance summary widget that displays prior maintenance history of the ESP under investigation with start date and end date for each task name and a short description. These work orders are listed in chronological order, with latest shown first. And the list includes work orders that are automatically generated by preset business rules for the ESPs previously identified as being at risk. And then in the top left of the dashboard, we have a filter widget that helps select an ESP in a time range to provide the context for all the other widgets on the screen. So here you can see we can select a location, and then once we select the location, we can select a pump, we can select a start date and an end date. So in this situation, I'm going to stay with ESP 701. I'm going to change the end date to 2015, and we'll do an update, and you can see that the change point analysis widget chart will change dynamically. Okay, so now you can see that the change point analysis chart has changed to show more information over a longer period of time. Collectively here, we've given the analysts much more information. They can drill down into the ESP, look at a historical perspective, look at the actual well test data, and get a better idea of what's going on. So as the demonstration has shown, the IBM Asset Analytics for Rotational Equipment and Oil and Gas solution can not only help customers identify the most at-risk assets, but it can also help understand the impact of such risk, understand the opportunity for remedial action, and create recommendations for performance tuning and maintenance.